Welcome to today's webinar, which will focus on sharing useful tips to overcome authorship dilemmas and will provide insights into open access publishing. We'd also like to welcome the We'd also like to welcome the researchers from Medizinische Universität Innsbruck who have joined us for this session. This webinar will have two sessions. We will begin with the topic How to Assign Authorship and Contributorship, followed by a short 10 minutes break, and the second session on the topic Open Science and Open Access. Today we have with us our expert speaker, Dr. Despina Sanadu. She holds a PhD degree in molecular cytogenetics from the University of Cambridge and currently works as an associate professor at the Medical School of the University of Athens. Dr. Sanadu is a renowned medical researcher and a published author with more than 88 publications, 4,400 citations, and over 20 grants to her credit. She has also been associated with Harvard Medical School as a postdoctoral fellow and an instructor. Before I hand over the mic to Dr. Sanadu, I'd like to give you all a brief introduction about Inago. We are the world's leading author services provider, and our author first, quality first approach ensures that our authors receive only the best quality output and excellent user experience at all times. This unrelenting focus on authors' needs means that we never compromise on our quality systems and processes at any cost. All our services are designed keeping in mind the author's needs. Enago Academy is our author training platform that educates authors through several resources, including webinars as well as live workshop sessions. We also have an e-learning platform for researchers called Enago Learn and a live one-on-one consultation platform called Enago Consult. Enago offers world-class services to researchers at different stages of their research career, such as two-editor system English language editing service, academic and non-academic translation service, manuscript preparation service, and publication support service. The Enago promise guarantees that a manuscript edited by us will never be rejected on the basis of poor language. On a rare occasion, if rejection occurs, we will take full responsibility for re-editing the paper for resubmission at no additional cost. Enago's comprehensive after-sales services will support you at every step of the way until your manuscript is published. They are designed to take care of every need from the time you receive our main services until you are published. Enago's research communication services are designed to help you effectively present your research data. In case you are interested to know more about any of these services, please feel free to email to us at academy@enago.com. Now, without any further delay, I hand over the mic to Dr. Sanadu to begin with the first session.
Hello, ladies and gentlemen. It's a pleasure to be with you today and very much looking forward to going through this always important topic. So let's discuss how to assign authorships and contributions when preparing a manuscript. The overview, today's agenda, will be, first of all, some information on authorship trends, how to assign authorship, how to assign contributorship, ethical dilemmas, and resources available to authors. First of all, let's start with an overview of authorship trends at the moment. The word authorship was first used in 1710 It's a way to give attribution to authors for their publication. It's it was easier in the academia to assign authorships when the papers were written in the past, mostly by single authors. Today, however, the extensive research collaborations necessitate having more complex authorship issues, larger teams, often each one involving multiple participants. So being able to assign authorship in a way that is fair, appropriate, and organized and completed in a timely fashion, it is an important skill to develop as one proceeds through their academic career. It's a way to invite credibility and accountability debates, of course, but this is something that one needs to learn how to successfully address. So why authorship is important? It's important because it's a way to give attribution for publications to authors. It has important academic, social, and financial implications. It's a way to convey responsibility for what is being published, and of course, it's a way to endorse the ethics and integrity of the work. If you look at authorship trends, the number of authors per manuscript changes across different disciplines and changes sometimes across different countries, but the primary parameter is the discipline. Let's look at, in these two graphs, at the number of authors in the different manuscripts that are being published. And as you will see, the most frequent number of authors is an average of approximately 3 point something, between 2 and 4 authors. This is the most frequent number of authors, average authors, if you look at the Web of Science. However, you can find publications with single authors or publications with many tens or even hundreds of authors. And when it comes to how many different countries these authors come from, usually it's from one country, but of course you have inter-country collaborations with many different teams, and you can often see publications with 2 and 4 and 6 and even more different countries that are involved. Now, coming back to this issue of number of authors across different disciplines, as you will see in this heat map, different disciplines have different trends in the number of authors. So, for example, in the area of mathematics, you most often see 1 to 5 authors. This is the approximately 99% of publications. In economics and business, again, the low number of authors is very common. But then when you go to disciplines such as physics, where you will see further down, of course, usually you have a low number, 1 to 5, but it can be as many as hundreds of different authors, or even over 1,000 different authors in rare occasions. Multiple authors are often seen in space science as well, but also in molecular biology and genetics. Now look in this graph here, the large difference between number of authors in physical sciences and biomedicine, for example. The number of papers with over 100 authors in the time period between 2002 and 2011 was considerable for physical sciences, but very limited for biomedical sciences. So this is a clear indication of how authorship is assigned and how different teams collaborate and what different sciences, disciplines necessitate in terms of collaborative work, and therefore authorship and acknowledgement during publication. These are examples of hyper-authorship cases. If you look both on your left and right-hand side, you'll see how many different authors are listed. And as you will notice on your left-hand side, this is only a snapshot of the authors in this manuscript. And these are all the authors whose last name started with B in this particular publication. But how do we go about assigning authorship? A very important parameter question to to know and an important skill to have. The ICMJE recommendations indicate that there needs to be a significant contribution to the conception or design of the research idea or acquisition or analysis or interpretation of data for the project. So actual intellectual involvement. Drafting the work or revisiting it critically when preparing the different parts of the content is another important aspect that an author needs to be involved in. The final consent to the version of the manuscript that has been prepared to be published, and the agreement to be accountable for all aspects of the work. It is very important to keep in mind that all authors share responsibility and accountability for the published content. They are responsible for having evaluated all the different stages of the work, having looked at the data, be in agreement with the interpretation and presentation of the data, and all the different ethical and different technical as well processes that have been followed. So every author on this manuscript is responsible for the scientific and the scientific component and the write-up of this work. So these 4 different criteria are recommended by ICMJE for someone to meet in order to be eligible to be an author on a manuscript. These are the official recommendations. There are now different types of authorship, as you already may be aware. There's the lead author, the first author, who is supposed to have contributed significantly to the work and to hold primary responsibility. So this is the person who will have performed experimental work or research work, who will have taken the main load of work of preparing the manuscript and coordinating different activities. There can be co-authors. So when we say co-authors in this context, we mean authors who have contributed equally either to the first author, to the last author, or equally to some of the middle authors. So in this case, you indicated with an asterisk next to this name and a clarification on the first page where it indicates which authors contributed equally. Now, in this case, there needs to be, as it clearly says, equal contribution, the equal contribution of this particular author to another author on the list. Usually this can be the first or the last author. Beyond the equal contribution, you have all the other middle authors in the manuscript, and we will discuss in the slides to come considerations for how to determine the priorities and the order of their names. And then you have the corresponding author who handles the official correspondence before and after the publication. And you have the last author who can be the corresponding author as well, but not necessarily. So you have the last author who is responsible for overlooking the full set of the project, of the experiments, of the publication, and coordinating communication between the authors. Of course, there are other individuals who may have contributed to the work in one aspect or another by offering advice, by evaluating parts of the text, by solving a technical problem, or assisting with writing some parts of the manuscript. In this case, if they do not meet the full criteria indicated in the previous slide, they are considered a contributor and they can be acknowledged as such without necessarily, or without it, they shouldn't be on the author list. So unless they meet the criteria indicated in the previous slide, someone should not be on the author list, but can be acknowledged as a contributor to this work. And this will be done in the acknowledgement section, as we will see later on. So the first lead author has had a major contribution, including writing of the manuscript, is the one who would have contributed or be primarily responsible for formulating the scientific hypothesis of the publication, selecting methodologies, participating significantly in the analysis and interpretation of the results, and writing the paper. As I mentioned earlier, additional first authors, co-authors, can be indicated with an asterisk and a clarification. The corresponding author is the one who should provide contact details that are unlikely to change, the one who will handle official correspondence from the journal, the readers, on behalf of all the authors, and will be responsible for doing that pre and post publication. It's a position that is usually assigned to the senior author, who is the supervisor usually. But corresponding author can also be the first author, or you can have two corresponding authors, first and last. This is a decision to be taken by the team, and to some extent it depends on what the journal allows. Usually two corresponding authors would be allowed in exceptional circumstances if this is the case. Now, corresponding author pre-publication responsibilities. This will include the adherence to the journal's editorial and publishing policies, will ensure that all authors have reviewed and approved the entire manuscript, will ensure accurate and updated information from all authors, and will ensure that all ethical practices have been followed as appropriate while conducting and reporting this research. During the submission process of the manuscript, as well as post-publication, the corresponding author has an additional set of responsibilities, and these include being the link between the journal and the different authors of the manuscript, is responsible for addressing queries or any issues raised by the journal, and ensures that they're addressed in a timely fashion and appropriately, is the one to follow up with all the participating authors of the manuscript to ensure that they provide their comments, feedback, or any additional work they need to contribute, following reviewers' recommendations, and ensures that this is done in a timely fashion, because as you know, when you start going through the submission and revision process, there are very strict deadlines to be respected. The corresponding author is the one who will ensure that the revised manuscript has been proofread carefully and is error-free, and will seek the feedback from all the different authors, will ensure that he or she obtains approval from all the other authors before submitting the manuscript, and from there on will be the point of contact for any further queries. Now, some additional information for co-authors and senior authors. A co-author, the one who has contributed equally to the first, the last, or some other author, needs to have contributed significantly to all the different aspects of the research work, along with the other person they are considered co-authors. This again is indicated by an asterisk and a clarification as to the nature of the contribution, if they're co-first, co-middle, co-last author. Now, the senior author needs to have formulated the original hypothesis, provide significant intellectual contribution, provided constructive criticism about the manuscript, and of course accept responsibility for the findings and authorship list. So the senior author is usually the one who has supervised, coordinated this effort, and overseen the work of all the other authors, ensuring the quality, the quantity where necessary, and the smooth flow of the work to be presented. Now, in group authorships, this is the case where author groups are formed when a research study involves a large number of investigators working as one single large group, and this does not necessarily mean that they're physically together in the same place. They can be a large group formed of participants from all over the world. So, as per the ICMJE's recommended guidelines, in the case of group author articles, it's important to bear in mind the following 4 points. Before starting the work, identify researchers who will take complete responsibility of the manuscript, the research work, and the write-up. Which individuals from this large group will be involved in the work for this particular manuscript. These authors, to be authors, need to meet the ICMJE authorship criteria. The corresponding author should specify the group name and the individual authors during the submission process, and list any other members that contributed but not sufficiently to be authors. Ensure that they are acknowledged in the appropriate acknowledgement section. Now, when it comes to the sequence of authors, this can also be very important. Beyond the first, the corresponding, and the last author, the senior author, the order of the middle authors can be very important for many practical, academic, etc. purposes. So it's important to weigh how much and in what way each member of the team has contributed and acknowledge their contribution by placing them in the correct order in the authorship list. And by correct order, I mean a fair position in the author list. So first of all, it's important to bear in mind the relative overall contribution that each individual has had to the manuscript. The first author is the one who would have worked probably the most as a single person for the research component and the draft of the article. The order of the authors should be a joint decision from all the authors, with the initiative of usually the senior author. Usually they're the one to put together the first draft of the author list. All authors, and especially the senior author, should be able to explain and justify their decision at any given time. In life sciences and medicine, as well as social sciences, the list of authors is usually based on the contribution. I'd say in the biomedical sciences, where my background is, it's almost always based on the contribution, the amount of effort, intellectual input, time devoted by each individual for the publication. However, there are disciplines, especially where very large groups of authors are involved, such as physics, where there are tens or hundreds or over 1,000 individuals, and inevitably in this case the authorship list goes in alphabetical order. So who is not an author on a manuscript, even though they've had some contribution? According again to the ICMJE guidelines, you're not an author if you have only contributed to the research work in the form of technical support, general support, such as from the department chair, administrative support, if you've only contributed in terms of financial and material support, or if you've only contributed in the form of some writing assistance. So if you have contributed in only one or part of one of these ways, but not in all of them, in the form that was indicated in the previous slides, then you're not eligible to be an author. However, your contribution should be acknowledged in the acknowledgement section, along with a clarification as to exactly how you contributed to this work. So how do we go about assigning contributorship? Contributing to research is broadly classified into the following three main categories. There's intellectual contribution with ideas and writing, ideas either in the organization, implementation of the project, ideas as to how the manuscript should be prepared, or writing parts of the manuscript, or improving parts of the manuscript. There's practical contribution when it comes to actually conducting research or helping with data analysis, etc. And there's financial contribution where funds or experimental material or biological material has been provided for this research work, for this project to be completed. However, if someone has contributed in any one or part of any one of these ways, but not the full criteria we've been talking about in regards to authorship, then they do not merit being an author, but they should be acknowledged as a contributor in the appropriate acknowledgement section that comes at the end of all articles. And this also involves any editing companies that have been assisting the team with the preparation of their manuscript, who, according to the ICMJE's guidelines, should also be acknowledged in the acknowledgement section. Now, when it comes to ethical dilemmas, let's look at some important issues that may arise when it comes to authorship. And these tend to be problems that, to some extent, most of us will have to address in the course of our career. And it's important to have a clear understanding of what these different problems can be, how to tackle them, what are the official guidelines. So, one ethical problem is what is called guest authorship, when a distinguished researcher is listed as a co-author, even though they may have not contributed at all to the specific research project or manuscript. Then the name is offered for the purposes of recognition or prestige, to boost the chances of accepting the article, for example, or to offer a favor to the particular distinguished scientist. This is something that would be unethical and inappropriate to do. Another issue that may arise is this of honorary authorship, where, for example, the head of a department or research facility or any other individual, for whatever reason, is listed as a co-author despite their lack of a contribution to this research work. I've seen cases where the individual may not be even aware of the specific project, and yet for honorary purposes, they're placed in the author list, even as a senior author. Sometimes authors can be faced with these challenging situations, either because they want to offer guest or honorary authorship to serve their personal scientific agendas. On the other hand, this is unethical. It's demoralizing for the other authors and creates a poor scientific culture, research culture in the department, in their team. There are cases when there are efforts to impose guest or honorary authorships from outside individuals to the senior author, to the official authors of the manuscript. Again, this is unethical, and appropriate measures need to be taken to avoid this. Another type of authorship that is also a problem and a very unethical approach is this of ghost authorship. A ghost author is an individual who has significantly contributed to the work, the research work, or the manuscript preparation, but is not listed as a co-author. So this is the exact opposite from what we saw in the previous slide. These individuals might include people with conflicts of interest or scientific writers who assisted with the manuscript preparation considerably but are not acknowledged for their efforts. And this can be a common problem in journals reporting large-scale clinical trials, like regulatory documentation and literature summaries. Of course, it is unethical not to place in the author list someone who has made a significant contribution and meets all the ICMJE guidelines. So this should be avoided. Now, what happens if we have accidentally omitted someone from the author list, or if we have accidentally included someone in our author list and we realize that at the stages after submission and before publication, or even later after publication? Of course, these are scenarios that should be avoided at all costs, and authorships should be very carefully weighed, discussed, and decided before submitting a manuscript for all sorts of different practical and scientific reasons. However, sometimes mistakes do happen, and then we need to take the necessary measures to address them. How do we go about doing this? If we need to include an additional author that has been accidentally omitted from the original version of the submitted manuscript, then the corresponding author should clarify the reasons for this change in authorship, obtain written consent from all other authors. If they all agree, then the new author completes the journal's authorship declaration forms, the details of the contributors and authors are amended, and this is then peer-reviewed and published. In the case, though, that not all authors agree to adding this new author, things are more challenging. The situation needs to be reviewed. The issue needs to be discussed further, and if there's no way to reconcile the different authors and reach an agreement, then the paper will be suspended until the authorship issues have been agreed between the authors and, if necessary, between the institutions. So this can be a very complex and time-consuming process that may considerably delay the publication of a manuscript. What if an author has been accidentally included and then needs to be removed from the author list? In that case, the corresponding author should clarify the reasons again for changing authorship, obtain written consent from all authors. If they all agree, the details are amended and then the manuscript proceeds with peer review and publication. If they do not agree, again, further discussions are needed. Publication is suspended until they can all reach an agreement. Now, what happens if these changes need to be made after a manuscript has been published? Now, this is even more challenging and definitely a scenario one wants to avoid. The corresponding author here would need to clarify the reasons again for this change in authorship, obtain written consent from all authors. If they all agree, the correction will be published. If the authors do not agree, then the author will have to get an explanation why this change cannot be implemented until all written agreement from all authors is obtained. Until this agreement is obtained, the author list cannot change. Once they reach an agreement, then the process is, as we described before, and the correction is implemented. Otherwise, we go back through circles of discussions until an agreement is reached. If it cannot be reached between the authors, then the different institutions are involved in order to reach a final decision and publish the correction. Now, if an author needs to be removed after publication, the first steps of the process are the same. Written consent needs to be obtained from all authors, including the author, to be removed from the author list. If they all agree, we proceed as usual. If they do not agree, however, and each one interprets the situation differently, then the different authors are asked to put their views in a letter and explain how they view the situation, why they think an author should remain or be removed from the manuscript, and if necessary, these letters can be published. If all authors agree to write a letter, then the editor contacts the other authors to clarify. The response is submitted by the authors. Both letters are published. Alternatively, if a response is not submitted by the authors, a minority view letter is published. If the authors do not agree to write a letter, a correction is published if the author further insists and the other authors agree. So as you can see, it's a very complex situation that take a lot of time and create a great deal of trouble for everyone involved. So every effort needs to be made to avoid such a scenario. Let's look now at some authorship decisions. The author sequence is often independent of the relative status or rank of the authors. Expected contribution, roles, and tasks of each author should be discussed at the planning stages of a research project. This can really help avoiding conflict at later stages of the project. It really helps if right from the beginning it is clear who is doing what, how much work, which specific parts of the research work, which specific parts of the write-up. Of course, this may change along the progress of a project. However, it's important to set out some outline in the beginning, and then if changes need to take place because of the developments of the research project, then these can be discussed along the way. But it's generally ideal to have resolved this before reaching the point of the manuscript write-up. Definitely, authorship sequence should be finalized before manuscript is written and submitted, for all the reasons we saw in the previous slides and many more. The author sequence can change over time as the needs of the project evolve, but again, it should be finalized before writing the manuscript. As we saw, any changes after submission or after publication will require a great deal of paperwork and discussions. But if necessary, corrections can be made, and now you know what the process for that is. Nevertheless, sometimes author disputes do arise. And from my side, all the researchers I've encountered, at some point, they've had to face such minor or major disputes over authorship. A researcher career and reputation is based on the credit of the work they do. And the main means for that is through the authorship, through their publications. So publications is a very important component of a researcher's CV, and therefore a very important parameter for their advancement in their career. Authorship disputes usually arise either for specific authorship designations, so in which order their name will appear in the manuscript, or when credit attribution is dictated by the individual powers of the different members rather than the actual work they have contributed. These are common reasons for authorship disputes. Adhering to policies and guidelines can be a very helpful way to prevent or disputes or avoid unresolved disagreements if they do arise. That's why the guidelines and the policies are there as a means to help us all avoid these situations and ensure that the same criteria are applied across the board, across teams, institutions, countries, and disciplines when it comes to acknowledging authors' scientists' contribution. Again, to avoid disputes, it's important to ensure clarity, disparity, ensure that contribution and authorship is discussed as early as possible, and a good justification is available for the position of every author along the authorship list. COPE recommends that authorship disputes should be resolved by all authors internally with mediation and arbitration if and when necessary. Inability to solve a dispute amongst authors can lead to article rejection or retraction, which of course sets a very bad track record for all the authors involved, so it's something that should be avoided. Now, to help the authors in this process, there's a number of different author resources available. So, in order to be able to identify authors and ensure that appropriate credit is given to them, all corresponding authors should provide their ORCID number, ORC ID. Every author is welcome to register and obtain this unique ID if you visit the ORCID website. This unique ID in a profile that you create in the ORCID database ensures that you have your unique identifier that you can use when submitting a manuscript, when publishing your work, or even when others are citing you or your work. And it can protect you for receiving the recognition that you deserve for your work, even if other individuals may have the same name as you, first and last name, and if they're working in the same field. So it's a way to ensure that you are identified always. It's in a way like your identity card in the scientific world. So ORCID is a persistent identifier that distinguishes you from every other researcher, solving the problem, of course, for multiple researchers having the same name. Usually journals will publish all authors ORCID ID upon manuscript acceptance, and it's often a prerequisite that you provide your ORCID ID for your involvement in a manuscript to be accepted by the journal and for the publication to proceed. So all authors are encouraged to register and use their ORCID ID. Now, other important researchers, you've heard me use a lot the term ICMJE. I assume that this is a term that you're probably familiar with, but just to ensure that we're all on the same page and also to provide you with the information in order to get more details if you want, ICMJE is the International Committee of Medical Journal Editors. They have their own website where you can find a lot of useful resources when it comes to authorship issues and more than that. ICMJE is a group of editors that promotes good practices in the reporting and editing of medical research. I think it's worth paying a visit to that website. You will find a lot of very useful information. It will also provide you with the tools and the guidelines and the best practice information that you will need in order to discuss authorship issues, avoid any disputes, and resolve any disagreements if they arise, because these are official guidelines that are out there and no one can argue that they would not apply in your specific situation, whatever that may be. Another important resource is the Committee on Publication Ethics. COPE, which is the short for Committee on Publication Ethics, provides guidance on several ethical issues related to research and publication misconduct. And then, of course, you can find a lot of useful information for authors in different journals. Different journals can have their own authorship guidelines, and it's always useful to check with the journal you're submitting your work to what their specific guidelines are when it comes to authorship, in addition, of course, to the guidelines for submission. Authors need to strictly adhere to these guidelines to improve their chances of acceptance. Deviating from what the journal requires for authorship can create considerable problems down the line. So, tips for researchers. All authors should preserve their scientific integrity and be accountable for the scientific and social impact of their paper. Our publications in the research world is the main way to showcase our work, the quality of our work, the quantity of our work, and to a means to be recognized for what we contribute to the scientific world. It's also one of the main criteria based on which we're assessed for our promotions, for inclusion in collaborations, for getting funding to perform our research. So authorship, recognition of authorship, order in the authorship list are very important issues. Ensuring the integrity of your work, the quality of your work is an imperative aspect of what you're offering in the scientific world. Being accountable for what you do for your research and also what you write in your manuscript is also a necessity. Authors should refer to the authorship guidelines in order to ensure that everything is done as appropriate and as agreed in a way at the international level. It's important to resolve any disputes courteously, to ensure the smooth continuation of collaborations, to ensure that everyone gets the credit for the work they have contributed, to ensure that teams can progress, collaborations can continue, even funded projects can continue as planned. Disagreements on authorship can really make teams fall apart. People with no significant contribution should refrain from claiming undue credit for a paper. This can create a lot of dissatisfaction, a lot of frustration among the other authors, and a intense feeling of unfairness. So it is important, especially for the senior author, to ensure the fair treatment and the fair acknowledgement of each person's contribution, and to ensure, again, that people who have not made a significant contribution are not in the author list. People offering significant contribution should ascertain the due credit. This can be in the author list, and if they do not meet all the criteria to be in the author list, it should be in the acknowledgement. So I hope with this information that you have now had a overall better understanding of the importance of choosing the authorship for your manuscript, placing the authors in the appropriate order, and giving credit when it's due, avoiding giving unfair credit to those who did not deserve it for the specific publication. And again, I would like to sum up the key points. In the authorship list, you need to be careful when it comes to selecting the first author, the senior author, the corresponding author, the order of the middle authors. Remember that you have the option of equal contribution, which can be equal contribution to the first, equal contribution to the last, equal contribution to the second author, etc. It's an option, not a regular practice, an exceptional situation that can be used. And for those who do not meet the criteria for authorship, you have the acknowledgement section.
All right. Thank you everyone for staying connected. We shall start with the second session now.
So in this second presentation, the agenda will be what is open access publishing, open data, open repositories and preprints, open peer review, open source and open educational resources, open licensing, open science, and the future of open in the sciences. Let's start by a definition of what is open. Open knowledge means and is any content, information, or data that people are free to use, reuse, and redistribute without any legal, technological, or social restriction. Key concepts in open knowledge. First of all, it allows the free, unrestricted, immediate, and online access. It permits reading, analyzing, copying, modifying, reproducing, redistributing of this knowledge, and ensures integrity, validity, replicability, collaboration, and inclusivity. There are, of course, challenges with the concept of openness, and some of the key challenges you can see in your slide here involve the potential unreliability, potential dissemination of inaccurate or irrelevant information, potential abuse of this open knowledge, which may lead to undesirable and uncontrollable sometimes consequences. It's difficult to maintain due to infrastructure or funding issues. So these need to be regularly checked and kept in place in order to sustain open knowledge. When we talk about open knowledge, there's many different aspects to it. So open knowledge can be open data, open access, open peer review, open methodology, open source code and licensing, or open educational resources. Let's go into each one of these different aspects of openness and discuss their key features, advantages and limitations, and challenges. Open access definition. Open access is the free, immediate online availability of research articles combined with the rights to use these articles fully in the digital environment. And you are probably all familiar with the open access symbol, which is shown in your slide here. So how did open access come about? It had to do with limitations in the budget of libraries, and I apologize, for some reason in the presentation the letters are not coming fully through as they should, but let me talk to you through them. So the limitations in the budgets of different libraries, together with increases in the expense, the prices for publishing, led the academia to come up with a different plan, if you want, and this was the option to be able to have open access publications. So it was around the late 1990s when we had the global transition and the increase in online usage and content delivery. So let's look at some of the economical aspects of the conventional model. Researchers are funded through public tax money or charity money, and they submit their manuscripts to traditional journals. Journals conduct peer review. Papers are published but are behind payrolls. So authors transfer copyright to these journals. Publishers also sell subscription to library institutions or researchers, and then researchers access and read their own work. Libraries, however, are also funded by tax money, but the taxpayer does not have access or has very limited access to these publications. In the open access model, however, researchers are funded through public tax money or charity money. Researchers submit their manuscripts to open access journals and peer review is conducted. Authors may have to pay publisher article processing charges to cover costs, but retain the copyrights. Publications are immediately accessible to public free of cost. And then researchers all over the world can access and read the published work. This maximizes, of course, returns on public investment. And complex as these two diagrams may see, they appear, they do give a nice overview as to the financial aspects behind the traditional and the open access model. Now, the different open access models that are available are listed here, and it's useful to keep them in mind because a variety does exist in the different publishing models when it comes to open access. So the most common ones are gold, green, and hybrid. The more rare ones are diamond, platinum, bronze, black, and libre gratis. So in these cases, the differences are whether the open access is paid, basically the publication, the cost of publication is paid by the author, and that's obligatory. This is the case in the gold open access publishing model. You have the hybrid model where the authors have the option of paying for their manuscript to become open access. And then you have the green option where all the manuscripts are paid by the author to be open access. Then you have the rare categories such as diamond, platinum, bronze, and black. The black is the case where you have the illegal availability of open access versions of the publications, and the gratis is worth making a note of because this is the case where the publisher has in their budget the funds in order to cover the cost for open access so that the authors do not have to pay for the manuscripts to become open access. Now, routes to open access publishing. Let's take, for example, a researcher who wants to publish and will submit to a gold open access journal or submit to a subscription journal. They have two options. In the case of the gold open access journal, there will be peer review, and if accepted for publication, they will have to pay the processing charges and their article will immediately become open access. Alternatively, they submit to a subscription journal, it goes for peer review. If accepted, they have the option of self-archiving it in a repository, and in the case of Green Open Access, it becomes immediately available to the public or with a delayed open access option, according, of course, to the publisher's policy. And then there's the option, of course, to have the paid open access option by publishing in a hybrid journal. Then you have to pay the processing charge if you want your article to become open access. If you don't choose the option of self-archiving in a repository or paying the publication fee, in the case of a subscription journal, then only those who have subscriptions to the journal will be able to access your manuscript. Let's look at a comparison of different publication models. How common is actually the gold, green, hybrid, bronze, or closed publication model? And you will see how this varies across different disciplines and how this has been changing again over time. The closed ones are the manuscripts, the publications that can be viewed only if you have a subscription to the journal, indicated here as gray. And you see how these numbers have been changing over the years and how the number of green publications and gold and hybrid publications have been increasing. At the same time, you will see how there are variations across the different disciplines in terms of percentage of green, gold, hybrid, bronze, and closed publications. And of course, things are changing within each one of the different disciplines. It is noteworthy that the majority of green, if you want, publications are observed in physics and mathematics. Now, article processing charges, you will see here how much the cost for a publication can be. What's the article processing charge in different journals? This can vary considerably. This is paid prior to publication in gold or hybrid open access, and it can vary from fees like $250 to over $3,000 for different journals. These are paid by the author, the funding agency, the research institution, etc. So the average, for example, in 2018 was around $937. But of course, as I mentioned, this can range considerably, and as you can see in this graph here, it can be even over $3,000 for one publication. The benefits of open access publishing, however, are very important. Improved visibility and access, shorter publication times, free flow of information, improved patient care because the scientific discoveries, the scientific observations, the cutting edge developments are available for the clinicians to read, learn, and apply in their clinical practice. And of course, ensures appropriate use of funding because you are making the most of the funds that are available for research. Challenges of open access publishing, there's always this side as well. Reputed journals are either subscription-based or are hybrid. Popular open access journals are not usually the highest ranked, not yet anyway. It can lead to an equal distribution, or I should say there is an equal distribution of open access journals in different subject areas. Authors have to pay extra, and it's important to pay attention to predatory open access journals. This can create an incentive for publishing in lower quality papers. And of course, there's the issue of questionable economic sustainability, which we will see how it evolves in the years to come as open access becomes more and more established and used. I would like to make a small parenthesis here and pause on the issue of predatory journals because their number is on the rise. It's sometimes tricky to spot them, it's important to avoid them, and it's an easy trap, especially for younger scientists, to fall in. In 2017 alone, a total of over 24,000 publications in approximately over 800 active predatory journals were reported. This is a very large number of publications that were published in predatory journals with all the complications and implications this has. Researchers from 146 different countries published in those predatory or fake journals. And as you can see in the diagram in this slide, a very large number of them were in India, Nigeria, Turkey, as well as multiple other countries. So when you're the author of a nice paper and you want the best for the paper and for yourself and your team, you come across the dilemma of where to publish this work. Publish in an established journal and pay no extra fees for publishing. Publish in an open access new journal of unknown future and fate. Pay the publication fee for publishing in reputed open access journals. This can be very high, and as we saw earlier, it can be even higher than $3,000 in some cases. Publish as an established journal with additional fees for open access. This is a dilemma that inevitably we all go through, and it's something you will have to weigh based on your own circumstances, the funds you have available, and the specific parameters that you need to take into consideration for your team, your project, your funding agency, your career, your department. So this is something you will have to weigh on a case-by-case scenario. Open data. Sometimes it is the case that scientists may pursue a publication at all costs, often putting aside valuable data, leaving it in a shelf, letting it go to waste as long as a publication with the key findings or some of the findings is out. But all this data, this incredible wealth of data that up until now would easily go to waste can now be made available to the broader scientific community through the open data model that is being developed. So some peculiarities about medical research data. Evidence-based medicine depends on quality and quantity of data. There are different stakeholders who generate heterogeneous data. They can be complex and variable, but all these different parameters can be analyzed and lead to meaningful, important results. Tim Berners-Lee's 5-star open data model can help us appreciate the different ways that open data can be made available. If we were to give a definition, open data is data that can be freely used, reused, redistributed, and intermixed with other databases by anyone, anywhere, for any purpose. So you have this 5-star rule. 1 star is for data available online in any format with an open license, including scanned copies. 2-star, data that are structured in a machine-readable format. 3 stars, when non-proprietary formats such as CVF files or Excel files, CSV instead of Excel files can be used. So this can be opened and used with a broader number of different tools. 4 stars, data that only uses open standards, for example, codes for indicating type of data. And then you have the 5 stars, which is for data linked to other databases using specific codes. So this is the most well organized and coded format. How can we share data though? This incredible wealth of data that is being generated around the planet on a daily basis. and the vast majority of which does not reach publications. So there are journals that are devoted to scientific data, such as the journal called Scientific Data from Nature Publishers, where they publish data per se. You have archives or digital repositories when one can submit their data. An example would be Dryad. You have institutional repositories. For example, MIT has their own, other institutions have their own, where you can, again, submit your data to make it publicly available. And then you have project-specific websites or peer-to-peer sharing tools for exchanging, making available the data, either within team members, but more importantly, for the open data culture, making it available to the international scientific community and the general public. Let's look at these points in a little more detail. Data journals specifically focus on publishing research data. They include description of the data, metadata, instead of the analysis of the data. And some examples are shown in your screen here. Giga and Science, Data in Brief, Scientific Data, etc. If you have a lot of data that you want to make available and you do not intend to analyze and publish in the form of a manuscript, this is definitely something worth considering. Now, an example of metadata would be in your slide here, where you can upload data in a CSV format, a JSON format, an ISA tab format, etc. So for the scientific data journal, there's different ways in which you can upload your data, and of course you will include your name, the context, a few details about this data set, where it's coming from and its characteristics, and then it obtains a DOI number, as you can see at the bottom of this slide, based on which one can track this data, cite it, use it, etc. And you can see here how many people have viewed or downloaded or cited your data. Advantages of sharing data: free access, which leads to discoveries and advances, facilitates the international scientific community, encourages citations as well as collaborations. People who will see your data may want to collaborate with you for specific specialized projects. It's a way to validate research, enhance validation of research and promote it, increases credibility and authenticity. It ensures compliance with funding and institutional body guidelines, because publications are an integral component of scientific projects and advancement of science. And of course, you have the opportunity to store, share, and cite metadata. There are inevitably challenges in the field of open data in medical research, such as the data heterogeneity, ethical aspects that have to do with what information you publish, how you publish it, etc., ensuring privacy and consent for any data that you're making publicly available. There's lack of predictability and long field observation periods that also pose a challenge in medical research open data. Now let's switch pages and talk a little bit about open repositories. What's out there, advantages, limitations, and how they can be of use to you. Now, when it comes to open repositories and self-archiving, you can post your pre-publication or post-publication prints in digital repositories. And this, of course, needs to be done in accordance with the journal guidelines, the guidelines of the journal you will be publishing in. Electronic archives are easily manageable cloud-based systems, and you are probably all well familiar with PubMed Central, but there's many others where one can make their publications available. They can be institutional repositories, subject repositories, data repositories. The number of different repositories is recorded in the Open DOAR database. It's a database worth visiting. This is, if you want, a directory of all the different data repositories that are out there, and you can see how the number of the repositories listed in Open Door has been changing over the years and has been changing very fast. In Open Door, you will find a broad variety of repositories specialized in your own field of interest, potentially from your institution or your country, etc. It's worth knowing what's available for your specific needs and interests so as that you can submit your data, or you can make the most of data that are publicly available to advance your project and science as a whole. There's different types of repository content. So you can have repositories for journal articles, theses and dissertations, books, conference papers, unpublished reports, data sets, patents, software. It's a whole big list of different repositories that are available worldwide, and different repositories that are available in each different country from each different country. You see that the largest number is currently of repositories is available from the United States. Second is United Kingdom, Germany, Japan, etc. Here's an example of the Indian Open Academic repositories. You'll probably be able to find different repositories from your own country, but all these are publicly available. This means for the international scientific community. So although they may be developed locally, they're addressed to the entire world. An example of an open medical data repository would be the SICAS medical image repository, which is a freely accessible repository containing medical research data such as medical images, surface models, clinical data, genomics data, etc. All this is made publicly available using a DOI number, so the identifier for the specific set of data that you are submitting every time. Now let's look at preprint servers. What are preprints and preprint servers? As a researcher, at some point you will prepare your manuscript for the sum of the work of a project. So you will be submitting it to a journal. It will be assessed by an editor, sent to peer reviewers, and months or years later, it will be published. An alternative route is you prepare your manuscript, upload it in a preprint server, and after several days, it's becoming available online. Meantime, you submit it to a journal, it goes through the editor, peer reviewers, and months to years later, it goes to publication. The advantages of submitting preprints to servers is that you can get credit for this work, you can get feedback from this work, and you can get citations for this work even before this manuscript is officially published. Of course, in this model, you need to ensure that the journal you will be submitting your manuscript to agrees to having submitted it to a preprint server ahead of time. And this is an increasingly popular trend. However, it's not something that all journals are agreeable to. So please make sure that you check before you follow this path. An example of a preprint server would be the BioRx IV, the preprint server for biology, as it's called by the Cold Spring Harbor Laboratory. And again, you'll see here an example of how you can submit your preprint. It has the title of the manuscript, the authors, it gets a DOI, and then includes the history and some information on this article. You'll also be able to keep track of number of views, get feedback, and citations for it. The advantages of preprints are that you can share updates for funding and job purposes. You can get more feedback that could even help you improve your manuscript while it goes through the journal submission, revision, and in more challenging situations, rejection phases. It's a way to announce your discoveries as fast as possible without having to wait months or years in order to announce that you are the one who's made a specific discovery. And this is often a good approach, especially when there's multiple labs working on the same project, competing for the same for the discovery of the same information. So with a preprint, it's a way to ensure that you've made publicly available the information of your discovery, and in a way demonstrate that you were the one to get this answer first before you actually complete the whole publication process. This means that your data, your manuscript, will be free access to the whole scientific community. Drawbacks of preprints: there are general restrictions regarding preprint acceptance. So as I mentioned, it's very important to ensure that the journal you will be submitting your journal to is okay, it agrees with having preprints submitted in public repositories. In the case of preprints, there's a tendency for hasty and poor quality submission of preprints to these repositories. And then, of course, you have the problem of multiple versions of the manuscript, because you will have a preprint in a repository. However, as you go through the journal submission, revision, potentially rejection phases, changes will be implemented to your manuscript. So at the end, there will be multiple versions of that manuscript available. Another aspect of openness is the open peer review. When it comes to open peer review, we're talking about open identities, open reports, evaluation reports, open participation, open interactions, open pre-review, open final version commenting, and open platforms as a whole. Some issues when it comes to comparing the traditional versus the open peer review. With the traditional approach, you have the established, proven way of proceeding. It means certain delays. It can entail unreliability or inconsistency. There's no benefit for reviewers since their work is not officially acknowledged towards the public. Reviewer comments and revisions are hidden from the public. Only the authors can see it, and the context is not available, of course, for the public. When it comes to the open peer review, you have a faster process, context is present. Of course, it's a new approach, less accepted so far. It leads to not as critical reviews because there's the fear of bad reputation, of criticism of the reviewer because of the comments they make. There's a bias for English speakers because of the hesitation by non-English speakers to make their comments publicly available. And there's a bias for prestigious institutions. So again, there's pros and cons with every aspect and issues that will need to be smoothed out over time. The other option of openness is the open source and open educational resources. Again, valuable tools for all researchers across different disciplines. So when we talk about open source software, this is when the source code is available free for inspection, revision, and distribution. And you can find such information in websites included here. You have open source software licensing that can be made available with or without licensing fees. You have lower acquisition, implementation, and support costs than proprietary software. And some examples in medicine would be OpenEMR and GNU Health. The former, OpenEMR, is the electronic health records and medical practice management tool. You can find it on the indicated website. And GNU Health is for electronic medical records, hospital management, and health information system integration. So you can find this again on the website indicated in this slide. Open educational resources in biosciences is another exciting aspect, and it's an area that has been becoming increasingly popular over the recent years. Needless to say that these open educational resources have been used heavily during the worldwide lockdown period of the past few months, because people were able to devote the time being at home to access and learn from these different sources. An example would be the MIT Open Courseware, where the courseware of different MIT classes is made publicly available in the form of video lectures, in the form of lecture notes, instructor insights, etc. And you can find this in the website at the bottom side, at the bottom of your slide. These would be resources for biosciences mostly. Open educational resources in medicine, an example would be from the Khan Academy under the section of health and medicine. Again, a broad range of different lectures and notes that are available and take you through different topics in great detail and clarity. Coursera also offers a broad variety of different courses for different topics, including medicine. And there's a long list of different educational resources that are available for you. Some examples are included in the slide you have in front of you at the moment, and you can obtain through Enago later on. Now, advantages and disadvantages of open educational resources. If we look at the advantages, these are resources that you can access anywhere, anytime, and of course, that's one of the reasons why they were so popular over the recent period. They're customizable, they have customizable course material, so you can choose, pick what is best suited to your needs and interests. You have enhanced course material, including videos, and a rollout changes rapidly, and of course, it's free access. There are some disadvantages to bear in mind, though. There can be technology-based access issues. There can be issues with quality and reliability, so you need to carefully assess where you find the information, who is behind the different repositories, is it a reputable organization, and also be careful of copyright protection issues when it comes to using material from these resources, these repositories. One more aspect to touch on is this of open licensing, the issue of copyrights. So when we talk about copyrights, we talk about legal exclusive rights given to a creator of an idea or work to reproduce, reuse, modify, or share the content. There are subscription-based models where copyrights are transferred to the publisher. A license cannot be added to a work without permission. And there are open access models where copyrights mostly remain with the author. Authors can give licenses for reading, copying, and reusing content. And in this case, they use copyright permissions to use a third-party content in the manuscript while publishing for open access. There are different types of licenses to keep in mind, and there's different symbols that come along with it. It's useful to be aware of the symbols and what they mean. We have prepared a summary for you here, but you're welcome and you may in the future need to come back and look at these symbols to refresh your memory. So when you see the C in a circle, means that there are copyrights associated with the particular content. It means exclusive legal right given to the creator or copyright holder to use a work and authorize others to copy, distribute, perform, display, and create derivatives of this work. There's the circle with two C's, which is Creative Commons, stands for Creative Commons. In this case, a set of licenses that give public permission to use and share creative work based on the creator's stated conditions. And then we have the symbol you see on your right-hand side, a crossed out C in a circle, which means public domain. This is a status given to works that were never or are no longer protected by copyright, e.g. government publication or works with expired copyrights. Of course, as we move from the left to the right on this slide, you have increased freedom in how to access and use the content of these works. Let's look a little bit in more detail the Creative Commons licensing. What does it allow? It allows copying of work, distribution of work, public display of work, digital representation of work, changing format of this piece of work. It applies worldwide without limitations in geography and lasts for the duration of the author's copyrights. These licenses generally don't have to be renewed, and it's not revocable, so licenses cannot be altered. There are, however, conditions for use of work under CC, the Creative Commons, so you have additional subcategories or symbols if you want. You have the case of attribution. You have so in this case you need to obtain the approval. You need to obtain the permission to use this work. There are cases non-commercial where you can use it but not for commercial purposes. There's no derivative works, they share alike, and there's as far as the public domain, in which case, as we mentioned, it's fully public and available. So in the non-derivative work, you can use this information, but you can use this work, but you cannot use it to generate derivative works, and share alike when you need to obtain special permissions to perform, to use this information, to use this work for downstream projects. So different symbols with different implications, and on your right hand side an even greater number of symbols to bear in mind. So when it comes to the Creative Commons, keep in mind the different subcategories, subclassification before you proceed with using this material in further steps beyond just reading and learning yourself. Examples would include the Karger Open Access Searchable Gateway, which is a CC BY license, as we saw in the previous slide. So in this case, you can use this information for non-commercial, as it's indicated, no derivatives international license with attribution. So you will see in the first couple of lines after the title Open Access Licenses, the specifics of the different licenses and clarifications thereof. Other examples would be for the PLOS database and the PLOS Open Access. Open science and the future of science. So in the open science research ecosystem, if you think about it, you can have open parameters in all the different stages of planning a research project, where you have open literature databases, open data repositories, and open data management tools. You have, again, open aspects in the active phase of a project, including survey tools, electronic lab notebooks, open tools for everything from collecting and creating to processing, analyzing, and writing your manuscripts. Visualization tools, analysis tools, writing tools. All these have their different open aspects and versions. And really we're entering an era in science where all these tools can make life much simpler and allows us a much greater deal of flexibility in proceeding, making things easier and financially realistic for many different teams with limited funds. Also tools for the publishing phase. So again, you have the open aspect in scholarly communication, in data publishing, and in assessing research with all the different parameters that we have been discussing in this presentation. So really, the ecosystem of research internationally is gradually transforming. So when we talk about open science, we're really talking about all these different tools that are available for all these different phases of a project and the integration thereof into the smooth day-to-day working life of a researcher. The benefits of science are many, but the key points are listed here for your convenience. It's a summary, if you want, of what open science has to offer to the scientific world. So first of all, visibility and access, wider dissemination of research, immediacy because the knowledge is published immediately and it's immediately available for utilization. Replicability and reproducibility because it simplifies the verification of published results. An easy and immediate way for public outreach and for making it realistic and easy for the public to participate, to understand, to follow advances in science. Better recognition because you have higher citation and impact of a researcher work. Global accessibility because countries with less resources can also now have access to current scientific knowledge. Policy making because authorities can make better decisions based on current scientific knowledge. And best use of the funds available for research by transparent spending of funds for research and avoiding costs that would be indirect in the research world and would take away from the funds that are available for the hardcore, the core, if you want, of research advancement. Challenges, as always with everything, there are challenges with open science as well. So at the socio-cultural level, there is inertia to change and it can vary from field to field. So adapting open science is a process. It will take time until people are more familiar and more accepting and more willing to participate and contribute to it. Technologically, it requires the appropriate infrastructure, which is also evolving over time. Economically, it requires funds for maintenance, so this has to be budgeted somehow. Organizational policies need to be set in place to promote open science. Political litigations and policies, again, to promote open science will be needed. And of course, a legal strong framework to prevent abuse needs to be set in place, both at the local, the national, but also the international level.
Thank you all and have a great day ahead. Thank you, Dr. Sanadu, once again.
It's been a pleasure. Have a good day, all. Goodbye.